In our previous slides, we introduced the idea of two major problems, the flatness problem and the horizon problem. So let me explain these two. Horizon, why is the cosmic background radiation so uniform? So the universe is big. In fact, it's so big, it takes the age of the universe for light to get from one side to where we are. Well, that means it'd take twice the age of the universe to get to the other side. So the other side has not had a chance to interact, with one side's not had a chance to interact with the other side. Well, they cannot be the same temperature because in order to be the same temperature, they have to exchange energy, but they haven't had time to exchange energy. So they should not be so uniform. And so, but they are obviously uniform. So to cosmologists, this was a huge problem. Why is it this way? The other problem is, why is the universe so flat? Again, we said statistically, the chance of being flat is like astronomically close to zero. And so it is so flat. So what does this mean? What's the consequence of it? Again, the horizon problem, the universe is not old enough for light to get from one side to the other to carry heat from one side to the other. So if one side were cooler than the other, then the hot side would have to have a chance to heat up the cool side. And yet there's no way that happens, because that would take twice the age of the universe to go from there to there, because it takes the age of the universe to get from there to there. And so there's no way. So something else has to be going on. There has to be some way that what's going on at one side of the universe could have interacted with what's going on the other side of the universe. And yet the universe doesn't seem. The flatness problem, curvature within experimental error, is close to 1. That's flat. Of all the possibilities, it's like 1 over infinity that it's flat. So very close to 0. And so this doesn't seem to make sense. So the universe should not be that flat. Okay. The density would have to be 1 part in 50 decimal places immediately after the Big Bang. Well, you never get that level of precision. So that's ridiculous. So why is it that way? Well, this is where we introduce something sometimes in cosmology called the Anthropic Principle. Why do we see the universe the way that it is? It seems that it can't be so random, okay? Because the slightest variation in any of the fundamental constants would mean that we don't have a universe. If the gravitational force were a tiny bit stronger or a tiny bit weaker, the universal gravitational constant were a little bit different, then that means that nuclear fusion would not hold up stars or would blow them apart. And if electrical forces were any different, that means atoms would either spiral themselves together or blow themselves apart. You wouldn't have atoms, you wouldn't have chemistry, you wouldn't have life. Of any of the fundamental constants here, if the curvature of space were such that pi were not exactly 3.1415 and so forth, then that would also change, the geometry of space and how all these physical laws work, and we wouldn't be here. Okay, there's two forms of the Anthropic Principle: the weak form and the strong form. So the strong form, people of religious faith go with the strong form, and they say, well, the universe is the way it is because someone made it this way and made it for us. So it is made for us. The weak form of the Anthropic Principle is, on the other hand, a statement that, well, duh, it's like it is. Because even if it's highly improbable, if it were anything different, there'd be no one here to ask, why is it like this? So even if it's highly improbable, it has to be this way in order for us to even be here asking. So if we're here asking, then that means it is this way. And so that's the two forms of the Anthropic Principle. Actually discussing them is fascinating, but beyond the scope of this. Okay. Next topic here is going to be the hot Big Bang, going through the different steps of it. So I'll start with that with a new set of lectures.